Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA Combined Science Physics Paper 1 Higher Tier, question number 6 from 2024. This is the last question from this paper. This question is on the topic from a particle model of matter. Now, question number 6, energy can be stored using a compressed air energy storage system, CAES system. When more electricity is generated than is needed, a CAES system uses the surplus electricity to compress air in a storage tank. When there is a greater demand for electricity, the CAES system releases the compressed air to generate electricity. Figure 7 shows a diagram of the CAES system. So you've got the surplus electricity passed to the compressor, which will be electrical, which compresses the air which is stored in the storage tank, and then can be really passed on to the generator, which would output the energy as electrical output, because a generator is basically a fan, and the compressed air, when passes through, the fan will spin, causing the motor to spin, causing the electricity to be produced. So the CAES system has two processes. Compressed air to store energy. The process has an efficiency of 0.72. Releasing the air to generate electricity. This process has an efficiency of 0.86. Now what they mean is, so the compressor has an efficiency of 0.72 or 72% efficiency when it's compressing the air, and the generator has an efficiency of 0.86 or 86%. Now, calculate the efficiency of the CAES system, of the entire system. Give the answer to two significant figures. 3 marks, 1 mark for you to give the answer in two significant figures. So, the efficiency, now you don't really need an equation because they've already given you the efficiency of the two systems. So as a whole, you'd simply multiply the efficiency. So 0.72 multiplied by 0.86, that would give you 0.6192. So in two significant figures, it should be 0.6. The generator works when the forces from the compressed air causes a turbine to rotate. When particles of air collide with the turbine, they generate energy to the turbine. In warm weather, the temperature of the compressed air increases, increasing the pressure inside the storage tank. Explain how. So you have to give reasons for it. The motion of the particles in warmer air causes an increase in the power transferred to the turbine. So if the air is warmer, that means the particles or the air molecules will have higher kinetic energy. If they have higher kinetic energy, then it means that they are moving faster. If they're moving faster, that would also mean that they're actually colliding more frequently and with greater force. Now remember, we are talking about the power. So if there is more force per collision, that means more energy will be transferred for every collision, which overall would increase the power, since power depends on the energy, right? So here's a model answer. At higher temperatures, the average speed of the particles is greater. So we're talking about the kinetic energy. So the frequency of collisions between particles and the turbine increases. So when I say collisions, we're talking about collisions between the particles, but that doesn't matter too much, as the particles hitting the turbines increases. And the force of each collision between a particle and the turbine is greater. So more energy is transferred each second. That you have to mention, because power is energy transferred per second. Next question. The volume of the storage tank is 5 times 10 to the power 5 meter cube. The density of the compressed air is 48 kilogram per meter cube. The specific heat capacity of the air is 1100 joules per kg degrees Celsius. So volume is V, density is rho, specific capacity is C. The temperature of the compressed air increases from 12 degrees to 27 degrees. So that's a temperature change. So delta theta equals 27 minus 12. That would be 15 degrees Celsius. And that should actually carry a mark out of the 6 mark. Calculate the energy transferred. So that would be capital E to the compressed air in the storage tank. Use the physics equation sheet. Now, to calculate the energy transferred, remember the equation E equals mc delta theta. Mass multiplied by the specific heat capacity multiplied by the temperature change, which we have calculated to be 15 degrees Celsius. We have the specific heat capacity, that we haven't got the mass, which means we need to work out the mass. They have given us the volume and the density. So the other equation for 6 marks is usually 2 equations. So the other equation is density is mass over the volume. So let's calculate the mass first. So density equals mass over volume. So density is 48 equals the mass divided by the volume is 5 times 10 to the power 5. Rearranging it, mass equals 48 multiplied by 5 times 10 to the power 5. That would give me 24 million kilogram. That's in kilograms. And that should give you another 2 marks. Right. Now let's use the equation for energy. Energy equals mc delta theta. So mass is 24 million multiplied by the specific heat capacities, that's 1100 multiplied by the temperature change, that is 15. That gives me 396 0 0 0 0 0 0 0 0 0. Right? In standard form, they're asking the answer in standard form, which is a mark. So up to this point, there's another 2 marks. So 3.96 times 10 to the power 3, 6, 9, 10, 11 to the power 11. So the final answer is 3.96 times 10 to the power 11 joules. The UK government wants the amount of carbon dioxide released into the atmosphere to be reduced. Explain why. Again, here's an explain why efficient energy storage is important in reducing the amount of carbon dioxide released when generating electricity. So, if we want to reduce the amount of carbon dioxide released during generating electricity, we need to reduce the amount of fossil fuels that we use to produce electricity. So that is to reduce the amount of coal, gas, oil that we burn in order to produce electricity, because combustion releases carbon dioxide. So if we want to do that, we will have to increase the amount of renewable energy resources, such as the one that we just mentioned. So, or we have to build new ones. Building new ones doesn't always mean that we are reducing it, because there's a carbon cost in terms of producing those wind turbines and all of that. So making more energy efficient wind turbine means that you have to build less wind turbines in a way, or solar panels. That means you are actually reducing the carbon dioxide on that side as well, not just by simply reducing the amount of burning fossil fuels. So here's a model answer. Efficient energy storage means less energy is wasted. To reduce carbon dioxide emissions, less fossil fuel is burned, or less fossil fuel should be burned or used. The amount of energy generated from renewable energy resources will need to increase, because if we are burning less fossil fuel, we'll have to increase the amount of renewable energy resources. Or most energy resources do not generate electricity all the time. Or wind turbines will not generate electricity when it's not windy, and solar panels will not generate electricity during the night time. So more efficient energy storage will help to meet the demand for electricity, meaning that producing electricity might be easy. You can produce a whole lot of electricity during the daytime, but if you can't store it properly, that means you can't actually meet the electricity during nighttime, because electricity is used more during the night or in the evenings than during the daytime. That brings us to the end of this question and to the end of this paper. Thanks for watching. Subscribe if you are finding this useful, and I will link the end of this video to other questions, or check out my channel for other exam papers. It includes biology and chemistry as well, both for separate science and combined science students. Thanks for watching.